Well, good morning or good afternoon, depending on where you are at, and welcome to our October monthly webinar. My name is Atarot Azizi Namini with Florida International University. I have the privilege of moderating today's webinar. Today's webinar is entitled Connecticut DOT's weekend closure to replace I-84 bridges over Marion Avenue. We have a privilege to have three very good speakers, Tim Fields, Mary Baker, Muhammad Bishtawi with us. During the question and during the registration period, we did receive a number of questions. However, it's not late if you have additional questions during the presentation. Please, by all means, post them on the dashboard, and we will do our best to answer them. And we will finish the webinar no later than 10 minutes after the hour. Couple of updates on the upcoming National ABC Conference in Miami. We have confirmed our two keynote speakers. We are very delighted to tell you that Congressman Mario Diaz-Balart and FHWA Administrator Gregory Nadeau have confirmed that they will be attending the conference and deliver the keynote talks on Monday morning, the first day of the conference. We did have a number of rooms at the special conference rate reserved for the attendees. All those rooms were sold out, but we were able to talk to the hotel, and additional rooms are going to be available in starting the middle of the next week. So if you tried to reserve your room and you couldn't, at least for one of the nights, please check back again next week. By middle of the next week, hopefully there will be additional room blocks, but we can tell you that those rooms are going to be gone probably very fast. We have almost used up more than 1,200 room nights, so rooms are going fast. So check with the website and reserve your hotel room as soon as possible. Another note is a deadline for online registration is Friday, November 20. Please visit the website. Make sure that you register by November 20 if you plan to attend the conference. And the website address again is 2015abc.fiu.edu. So at this point, I'm going to turn it to Mary Lou to share some news related to the ABC.
Thank you, Atorad, and welcome to all. As mentioned last month, the ABC UTC is hosting its second in-depth web training on November 10th from 11 a.m. to 3 p.m. Eastern. The topic is the Milton-Madison Bridge Lateral Slide Bridge Replacement Project. The topic was selected based on your interest in this project when it was featured in one of our previous monthly webinars. The webinar training will consist of 6 40-minute modules by the Milton-Madison experts for the module topics as shown on the screen. The presentations will each be approximately 30 minutes, followed by a Q&A session that will allow participants to ask their specific questions and have them answered by the experts. Online registration is open. Cost is $150 per site for all 6 40-minute modules. Next screen. And then next screen. You can access details on the training and online registration on the ABC UTC homepage as shown on the screen. Registration for the 2016 PCI Convention and National Bridge Conference will open within the next couple of weeks, with early bird registration ending February 1st of 2016. For more information, please check the PCI website or contact William Nickus as shown on the screen. FIU, FHWA, and the ABC Project Database Steering Subcommittee are pleased to announce that the ABC Project Database will be available on the ABC UTC website next week. The project database was originated as the FHWA National ABC Project Exchange. The bridge project data in the exchange were imported to the ABC UTC's website. You'll be able to access the project database from the ABC UTC homepage as well as from the Technology Transfer tab. The project database is being developed under an ABC UTC research project entitled Compilation of ABC Solutions, as shown on the website under the Research Projects tab. The principal investigator for this project is Dr. David Garber, professor and researcher at Florida International University. This is a view of the project database homepage. Available on the right-hand vertical menu will be training videos to help you become familiar with the database. By clicking Updates Comments Assistance, you will be able to provide updates and other comments on projects currently in the database and also request assistance on any issues that you may have in using the database for your purposes. The email will go to Dr. Garber with copy to me. David and I will then together work to respond to your emails. The database currently has about 100 projects and more are being entered. The database subcommittee encourages you to submit proposed projects to be included in the database. Project submission is a two-step process as described on the website. You'll be able to click Submit Project on the right-hand vertical menu to begin the submission process. A research database similar to the project database is being developed and will be available by the end of the year. As mentioned last month, the ABC UTC also invites you to become mentors for graduate students working on ABC UTC research projects. Please contact Dr. Brent Fairs at ISU if you would like more information on becoming an ABC mentor. The presentation for next month's webinar will feature the Iowa Buchanan County's first use of KUHPC in one of their bridges. The presenters will be Brian Kierlieber, Buchanan County Engineer, Alex Davis, Assistant Buchanan County Engineer, and David Lee, Professor with the University of Iowa. The webinar will be held on Monday, November 30th. Please mark your calendars. Today's webinar features the Connecticut DOT's SPMT move to replace their I-84 bridges over Marion Avenue during a weekend closure. Presenters are Tim Fields, Connecticut State Bridge Engineer, and Mary Baker and Mohammed Bishtawi, both transportation supervising engineers with the Connecticut DOT. Tim?
Thank you, Mary Lou. I'm Tim Fields, Principal Engineer and Bridge Consultant Design in the Office of Bridges with the Connecticut Department of Transportation. With me is Mary Baker, who is going to speak about the design phase of this project, and Mohammed Bishtawi, who will be speaking in regard to the construction phase. Before we get into that, to speak to this particular slide, I want to note that we basically kicked off our ABC practice in Connecticut in 2011 when we put out a notice to all our designers here that we wanted ABC considered in all projects. Prior to that, though, we actually had what I call several ABC projects before we called it ABC. Back in the 90s, we did two bridge deck replacement projects. These were significant projects using pre-cast deck panels. And then in 2004, we did a single pick on a 300-foot truss that was part of our Church Street extension project, which is in the database right now. That was an 800-ton pick that was dropped over about 10 track widths, and these were electrified railroads. So we were, in that particular project, driven to the ABC by cost. But to speak to this project here, before I get into this here, I'll just note that we, given the number of ABC projects that we had done, we were keeping our eyes open for a project that would be suitable for SPMT or lateral slide of a superstructure. And as we got into this particular project, it became evident during the early design phase, that this was a very good candidate for SPMT. The particular span is, this is about a 102-foot span, constructed in 1963, and Mary will speak a bit more to that. But Mary, at this point, I'd like to kick off to you.
Thank you, Tim. Hello, everyone. Mohammed and I have really enjoyed the success of this ABC project, and we're happy to be here today. We've been able to present this project to several groups. The Southington Superstructure Replacement Project really helped DOT here in Connecticut transform our bridge program and increase the use of ABC. This slide here shows the map of Connecticut. You'll see our major interstate routes and expressways in the color purple. Southington is located in the center of the state along Interstate 84. It's located just north of the east-west Interstate 691 that connects I-84 to 91. So we have good interstate and expressway alternate routes here. This is the aerial view of the site at I-84 Interchange 30 in Southington. The interstate crosses Marion Avenue, a local road. Notice the ample area, all state right-of-way, within this interchange because of how the off-ramp heading eastbound exits onto Atwater Street. The village of Planceville is just to the east or right. Again, the bridges were built in 1963. Both superstructures were in poor condition, and each bridge carries 3 lanes of traffic with an approximate volume of 86,500 vehicles a day. So traveling on 84 eastbound here, before you get to this exit, you would have to see an exit for our truck stop, which is a very popular venue on exit 28. And also between that truck stop and this exit here on Marion Avenue, we have a rest area for travelers. Here is the elevation of the eastbound bridge. The vertical clearance here is 21 feet 8 inches. And here is an elevation of the westbound bridge. The vertical clearance is 15 feet 10 inches. That was the existing, both of those that I noted. Notice the grade of Marion Avenue heading away out of the picture, which is toward the village of Planceville. We had a look into that grade. So when we go out to the public, it's difficult for them to understand the need to replace the superstructure. So when you're looking at the fascia beams, you don't see as much, but underneath here you can see the conditions of the existing beams. So there were hollow areas, cracking, exposed reinforcement and tendons. The girders also had longitudinal cracking. Here's an example of the condition of the beam ends. Several beam ends had diagonal cracks with large surface falls, exposed rebar and tendons. The substructures of these bridges were in good condition, so our project involved replacing the superstructures. We reviewed different options to maintain traffic. Originally, upon a request, our designer presented stage construction plans maintaining 2 lanes. However, our DOT traffic unit expressed concerns about that volume of traffic being able to be effectively carried in 2 lanes. So Stantec, the designer, reviewed the cost of widening the bridges to that interior median side for both barrels of the highway and staging the project using 3 lanes. They also reviewed the ability to have a crossover at this location and utilize a temporary bridge. Close Jensen and Miller, our liaison firm that worked with us, they researched the use of these SPMTs, and they estimated costs. And here are the options that you see on the screen. Really, they were all fairly competitive from a construction cost standpoint. However, adding in the user costs and inspection oversight, the ABC alternative really was our best choice. So we selected SPMTs. We're confident that both barrels of 84 could be replaced in 1 weekend. The contract documents provided for a 56-hour maximum closure, and using ABC provided for the safe work zone, allowing us to minimize the disturbance to the traveling public and the nearby businesses. ConDOT here, it was interested in joining other states in constructing projects using prefabricated elements or ABC techniques. We all had the same goal, is to get in, get out, and stay out. The designer detailed these 48-inch New England bulb T-girders for the superstructure replacement. Since the abutments, again, were in good condition, we chose to stay with the pre-stressed girders to minimize the substructure work and to stay with the same girder spacing. 10 girder lines per bridge were maintained. The plans call for minor abutment modification and pedestal reconstruction. A steel option was reviewed but found to require more abutment reconstruction and more cost. As you can see here, this configuration, we had that area, really a nice area to stage the bridge. It's noted in green, where we call for prefabricating the superstructures offline, not impacting the 84 traffic. So the designers gathered the information from the SPT companies. They looked at how they could manage them in the staging areas. They reviewed the lifting weights of the beams as well as the movement capacity of the movers. So this layout appeared in the plan set. Our primary contracting method here in Connecticut is design, bid, build. So we provide the bidders with our plan sets and with this potential scheme. To read more about the design and construction of this project, you can review Aspire magazine. The summer 2015 edition included this article by the engineer Andy Lassard, who works for Stantec. It's a nice article to review, and you can download that online. Whoops, I advanced too quick here. Hold on 1 second. So we knew in design that we had a difficult road ahead of us regarding the public outreach. Department Bridge and Traffic staff held meetings with the Town of Southington manager, engineer, police, and fire chiefs. We gained their approval of the idea for the closure of the I-84 and held a public information in 2011. The design group continued to assist the construction team for all of these listed meetings you see here. We held a pre-bid conference for contractors to review the many questions we received during the project advertisement regarding the timeline, incentives, disincentives, and other items. We met with many local groups, and our construction team offered tours, site visits for our fellow DOT staff, because this was new to us, and even Southington High School engineering students. But our outreach was more than just the local area. We coordinated with neighboring states and federal agencies. Emergency management coordinators contacted area hospitals. We even notified the FBI in case they were transporting officials or prisoners. At our local meetings, we showed all the detour routes. There was a short local detour around the site, so that was easy for residents in town. Because the bridges were located at the Diamond Interchange, we chose to route one lane of 84 traffic along the on and off ramps, so one lane went down and back up. Doing this, we did contain the contractor to the inside of that traffic flow. That was something to consider. The Southington Police provided us with this slide. They were really instrumental in doing the public outreach with DOT, and they even attended meetings on their own, and they showed this graphic at their meetings, and we used it as well. So this next map, it's not meant for you to all read, but it was our tool to look at our locations that we have existing for our highway operations and management signs. So the Southington project used about 20 to 30 of those signs, and we had the contractor add 11 or more so for variable message signs. The incident management signs were just that, so we had to acknowledge that if there was an incident, our incident management signs had to say, you know, a missing person or traffic alert to some other avenue besides our own project, but we had them live during our project. We used them in advance of our project to display certain messages about when the project was coming, really to give that forewarning. So there's a lot of conversations with our traffic group about what the signs should say and when we should display them. Here on this site, on this map too, you can see in red the bypass route. So our bypass for the interstate was with that, just other interstates, 691 and 91, back to 84. The press gave good coverage of our activity, both local and state papers. If you still read the paper like I do, they cover the news of the upcoming project. Here's our Department of Transportation Commissioner, Jim Redeker. He surprised us with a visit to the site during the week in construction. We provide him a vest and a hard hat and escort him right near the movers. This photo is taken with the eastbound bridge in the background ready to be moved. Shown here with him is Terry, our work zone safety coordinator. She's since retired. She was recognized as Employee of the Year following the project. She worked really hard with our communications office. We had the state police sergeant film a radio TV announcement that notified the public about the upcoming work. So the months prior to construction, she organized our team traffic meetings with design, construction, and the contractor staff. So we held meetings at the Southern Police Department with local EMS and state police. So I encourage every DOT to assign a point person who's going to manage their communication and work zone safety meetings. And this was a construction pass. We had this printed to limit the access to the site during the move, construction staff and the contractor staff. And Mohammed will speak just to that, all the construction activities.
Good afternoon. Thank you, Mary. This is Mohammed Bishtawi. I'm a supervising engineer with the Department District 1 Construction. I've had about 31 years working with the department, mainly in construction. I just want to give you a little idea before I get into the specifics of the construction, just give you an idea how we do things in the Northeast, because we're a little different, I guess. So we have people from all over the country. We have a construction season that starts April 1st and ends November 30th. So, and then we go from December 1st to March 31st, basically as a, what we call winter shutdown. This project was intended to be done in one season, and it was supposed to be done in 2013. One of the approaches we had to do also was, you know, like Mary mentioned, we did have a pre-bid conference with all the contractors. explain to them our scope and what we're looking for so they know what they're bidding. And after the job was awarded, or the bids were open, we did have a meeting with the low bidder to make sure to have that confidence level that they know what they're getting themselves into and that they can do the job and answer the questions for us. So we were supposed to start them early. We were supposed to start them around April, but after our meeting with them, we decided to take a full 60 days between award, from bid opening to award, and then also to take full 45 days after award to notice to proceed, to be able to move the car this way, pushing the job to the following year, and use that time to review all the submittals. There were a lot of submittals associated with this job, a lot of shop drawings, a lot of working drawings, a lot of analysis that had to be done, in addition to some of the utilities that we had to do. So basically, the job was awarded in June 7, 2013. The notice to proceed was for July 22nd, 2013, and the completion date was July 7, 2014. So most of the work was basically utilities doing during the time between 2013 and 2014. The contractor was Northern Construction Services Service from Weymouth, Massachusetts. You can see some of the low bid was $6,031,000. The high bidder, we had 4 bidders on the job. The high bidder was $7.6 million. The third bidder was $7.2 million, and the second bidder was about $6.6 million. So it wasn't far apart how we ended the project. The revised amount total was $7.4 million. Sean Hoy was the project super. He has a PE license, also master's degree in engineering, which helped a lot with him managing the job and knowing all the issues that we had to go through. The contract was for 230 days, basically. Here are some the contractual items that we have in the job, and you can see basically we have 3 kinds of liquidated damages, and we also had incentives. The calendar days, basically if you go over 230 days, that was about $2,000 a day. The lane closures for the pre-stage was about, it varied depending on the lane, eastbound or westbound, so you had also certain hours. And the weekend closure, which I'll get to in the next slide, and we also had incentives for you can see the liquidated damages for a weekend closure basically were about $100,000 per hour per lane for each direction of I-84 or any portion thereof. However, this added up a lot. If somebody was going to be late for a day or two or a few hours, there were a lot of questions during the bid phase, and the department decided to limit the ceiling for the liquidated damages to $100,000, to $1 million, excuse me. These were the incentives that also were given to the contractor. There were much also, it was kind of a late decision to add the incentives. We added an addendum, and given the contractor $250,000 if they finish on Sunday by 10, $200,000 if they finish by noon, and only $150,000 if they finish by 5 o'clock Sunday. I'm happy to let you know that they did make the $200,000. They get the incentive for $200,000 for finishing, having the highway ready to be open by noon, even though we opened it later for final paving and final markings and other things, but the intent was met for him to open the highway by noon Sunday. There are 3 stages. The contract was made 3 stages. Stage 1, which was the median wing wall parapets modification. Stage 2, the outside wing wall parapets, and Stage 3 was the weekend replacement. We were supposed to maintain 3 lanes of traffic on I-84 during stages 1 and 2, and for the weekend closure, basically we're shutting off the highway, but we kept the ramps open. This is a schematic of the high-speed contract median wing wall parapet work, showing the stage that was needed to be done. And this is basically the other side, the right side, for construction of the wing wall parapet that we did earlier. In all honesty, that work could have been done later, but it we had it done ahead of time, it was okay. But we found out that it wouldn't have affected anything for the weekend closure. We could have done it after if we had to. This picture, I just wanted to show you one of the beams. This is, Mary mentioned that this was a New England bulk T-beams, 102 feet, precast beams that came to us from Pennsylvania. They were made in there. The width was about 150 to 56 feet curb to curb of the bridge. The bridge was on a skew, a 30-degree skew, and this was a fascia beam. As the beams were arriving, the contractor was so eager to work. He started getting ready, and you could see that he started put the platform before we even started putting the before we erected the beams on the job. This is another shot this is the West Pond staging area where we built the bridge, one of the bridges. We're using 600-ton crane to set the beams for the area. Point of worth mentioning here, if I can get the mouse to show the arrow, is we had on the West Pond area only to put the beams under the bridge and eventually pick them up with the transporter when we are ready to make the move, due to the geometry and the way the ramp configuration is, and since the ramp was going to stay open during that weekend. So this was a special arrangement that we had to do for the West Pond side. All right. This chart showing the East Pond staging area with the East Pond bridge. The beams were already put together. We poured the concrete diaphragms during that offsite, as you can see. We also had to build the stairs and everything, and this was about 22 feet high. It was kind of built to resemble the final position that the bridge was going to go on once we actually move it. So this was about 22 feet 6 inches high and was built right there. Okay. This is just again to orient you with the staging area. This is you can see the East Pond and the West Pond. In green, you see the major bridge staging area number 1, which we have built the bridge, and bridge staging area 2 for the West Pond. This wasn't the original intent. The concept that the department had or the designer had was to build the 2 new bridges in the staging area 1, and once we remove the bridges, to put one of the bridges, there are 3 bays. I'll try to see if I can point them out. If you could look closely at the drawing, you see 1, 2, and 3. This was our original concept, but we also were open for any contractor suggestion, how he was going to do the moves. Staging area 2 was just going to be used for storing the bridge during the move one day, and that was all it was going to be used for. It wasn't going to be used to build the bridge. However, the contractor came up with a different plan to do the bridge, how to do the work, and sequence it. This is the contractor plan, was to build East Pond Bridge and the East Pond and West Pond Bridge and the West Pond staging area. And this was a major factor. I think Mary touched on to this about Marion Avenue had a profile, was a 3.56% slope. And then when the contractor did the analysis, they figured with the weight of the bridges and the SPMT that they can only traverse 2% slope safely and with stability. So that's one of the reasons. So because there is a sag between the 2 bridges, so if we were supposed to carry it right in this area, there's a major sag dip in the road, it would have been tough to safely carry the bridge to the other side. So that was one of the reasons. And also, so he decided instead of removing 2 bridges with the SPMT, is to remove the East Pond with using the SPMT and demolish the West Pond in place. And he actually thought that he could save about 12 hours from the 56 hours by doing it that way. This is showing the path, the travel path of the SPMT. I just want to mention that the SPMT speed was, the maximum speed was 0.3 miles per hour using that. And we had to do geotechnical analysis. The contractor did part of the specs on the staging area to make sure that the whole staging area can take the weight and of the SPMT. And because of that, the contractor ended up putting some HDPE mats and using some steel plates on the road to make sure that the SPMT travel path is stable and no surprises there. Again, this is showing the actual weekend, how the contractor, now you will see on the animation, how the contractor actually planned on doing this work. And then this is showing how when we close 84, you could see the arrows pointing to traffic just getting off and continuing on. Same thing going eastbound, getting off and continuing on. And Marion Avenue was totally shut down, barricaded using concrete barriers on the southern end and the northern end, basically. And that's all the area contractor is going to work with. He also opened the area between the two bridges. He made a road, a path for him to access the top, so we can access eastbound and westbound at the same time with equipment that he was getting. So here's the animation of how the contractor was planning on doing this. Basically moved the westbound bridge outside like early on, which was Friday morning before the move, and this was going to give us a test if everything is well. The load is stable, the SPMT handled the load and was able to move, and that was supposed to be doing Friday morning, only closing half of Marion Avenue. Now, here is what the rest of the animation, removing eastbound, and also demolishing westbound is fading away, being demolished in place, and moving eastbound into place, and then once westbound was totally demolished, move westbound into place. One of the requirements we had for the contractor was we made him provide, it was part of spec to provide an hour-by-hour schedule for the whole weekend operation. And he did show, like I said, he was shooting for the 10 o'clock Sunday morning, and his schedule did show that and showed actually enough float for that to happen. And unfortunately, other things will happen, and some of unforeseen things took place, and it took us a little while, and he still met the incentive and got the $200,000. This is the closure schedule. This is how it was supposed to happen. I just want to point out that the first point where it says 9 a.m., Southington rest area, this wasn't part of the original scope or part of the plan. However, during our meetings that Mary alluded to, we had about 2 months worth of meeting almost every week or every 2 weeks with the police department and everybody. And we had state police involved and city police involved. And they suggested to use, we have a close by rest area, to use it as a unified center, command center, and put computers, and then we can watch the cameras, and also this way we could also communicate with the troops. We have troopers on the side, and any issues that arise. And it was manned by maintenance, construction, we had city police, state police, we had fire department represented, and ambulance department also were available for the command center 24 hours. So, and then at 5 o'clock, we were supposed to close Marion Avenue, like I showed, to box where the work area is going to be. And we decided also to close the ramps at that time, since nobody could turn on left or right at the same time. So the contractor was getting ready. And original peer plan, we're supposed to close the highway totally by 9 p.m. You can see there the sequence that we're able to take 1 lane, 2 lanes, and eventually take the full 3 lanes. And we did the move on June 27th, Friday night, and we were supposed to finish Monday by 5 a.m. We were lucky to finish a little earlier. This is a shot showing the eastbound bridge being removed, and you could see with the SPMT that it carried it and moved it. And actually, this is also showing the same bridge moving into the staging area. And I just want to point out these HDPE mats in here. One of the issues we had also, there's a tree in the back. As we were trying to make that turn, the tree was in the way. We had to do some tree trimming that wasn't planned on during the move. This is showing the demolition of plan or schematic that the contractor submitted to us for the westbound bridge. And it's basically, it was going to be a double pick, 2 cranes, 1 on each side, pick up the beams, saw cut longitudinally along the beams, and pick them up and drop them in the ground. And this is an actual picture showing, slide showing the two cranes in place. The east span was already moved, and you can see that in there. And also, it was like once we dropped the beam on the ground, it was supposed to be steel plates. We're supposed to use a cat dozer equipped with shear, hydraulic shear, to cut it to pieces and move it to the laydown area. And there's a slide here showing the actual beams being picked up, and you can see the cat dozer there on the side trying to do it. And what they did actually was something, these guys were experts on doing what they had to do for demolition. They placed the beam on few mats, crane mats on each side, and then they just roll the beam and it break in half, and then they have the shear. You can see the shear there. They break it at the side and move it to the laydown area. And this is a shot showing after we removed both beams, the only modification we had to do to the substructure was cut down the back wall, horizontally cut the back wall, and excavate behind the back wall to put the approach slabs, which were precast approach slabs. And we only needed one modification to the existing concrete pad. We didn't need to do much in that. This is a shot showing the new bridge going into place for the east span. And I just want to point out these things. I mean, this was basically, this is the SPMT. It was made of, basically for each bridge we had 8 trailers, 2 in tandem and side by side. We had part of the contingency plan is to have these power packs. This was also like a contingency, wasn't needed, but we have it there just in case one of them breaks down. And this whole thing was operated by a guy with a joystick. A lot of people were interested in how much he is getting paid. I had no idea. But he had the cool job. And I just want to show you in this picture, you could see the block in here. We have what we call the gantry system. There's a pull-up gantry that can go about 60 inches up and down to move the bridge up and down. We also had for the transporter itself, the deck, those axles, the 12 axles on each two, I guess, a 6 per trailer. Those have also, they can go up 3.5 feet up and down while the deck is maintained level, basically, and that was a very important thing. And as we started doing the work, I just want to point out to the blocking that we have, even though it's hydraulic force, but it's they made, I want to make sure that nothing fails so it doesn't fall. So they would raise it like a few inches, put the blocks in, and make sure on all sides, and then raise again and put more blocks. And they kept doing that, so that process took about 3 hours just to raise the bridge, to remove the old one, and the same thing for the new bridge. This is showing the westbound bridge also being ready to move into place. There was a question about monitoring during the move. We inserted, the fascia beam did have wires inserted on them for monitoring. Also, during pouring the deck, we installed some wires for monitoring. A consultant was hired by the contractor. I don't know if you could see, but right on top of the bridge, there were some prisms and there are some strings in there, and there to watch any move and you know, anything that happened, any twisting, any changing of the operation. It was being monitored throughout the move. This is a schematic showing the contractor submitted that during the analysis of the move, and showing us exactly calculating the weights, how many trailers we needed, and the trailers had to be in a skew. They had to be staggered in the trailers also, how to build up the trailers with the gantries. And like I said, we had 2 different bridges, so we had 2 different SPMTs of 8 trailers. Those trailers came to us from all over the country, came from Tennessee, from Arizona, some came from California, and the whole team that did the move also, they had also came from all over the country, Barnhart, and the team collectively had done 9 moves before this one, so we had good insurance or assurance that this thing would go well, but still you always have that 1% doubt in your mind, and it still was able to be done. Like I mentioned, the speed of the SPMT was 0.3 miles per hour. This is a 3D scheme of also the beams and being carried and the bracing that we had and the heights. One of the few things that I need to mention is the constraints were if we had winds over 25 miles per hour, we weren't going to go. If we had more than 1 inch of rain per hour, we weren't going to go. And but everything else seemed to work. It was a good summer day, June, and everything went well. This was a nice shot Mary took. One day she came off the bridge, and we have an area in Plainville close by to Southington, and they have air balloons in the area. And this picture you could see we have cameras actually. We have our own highway operation cameras. One of the things we did for the job, or we added to the project, is to have EarthCam, which had a streaming video for us and did a time lapse. So we were able, it was a great tool for us. It was a great tool for everybody. It kept a lot of people away while they sat at home and they were able to watch the whole move from home, and the managers were able to keep up with that. And it was a nice thing, and it really helped us a lot, and we definitely recommend that for any future project to have the time lapse in there. Now I'm going to go over to discuss what we had to do to make it on time, to finish the job on time. One of the few things, like I mentioned, this was added to the job, was having a traffic management command center. We did in the rest area. The DOT CHAMP, we have our own maintenance, our own vehicles that patrol the highways and help broken down cars or motorists, because we couldn't afford along the routes for any vehicles to be disabled in there. So our highway operation was monitoring that, the command center was monitoring that, and these vehicles that we put them on all our routes during construction so they didn't have an issue. Our IMS system response, like I said, we were tied down with the police and everybody, and fire and our highway ops and maintenance also had their forces ready for us just in case anything goes wrong anywhere on the highways. So they were on alert working with us. We had a traffic management plan for the project. However, it was very basic, and during our meetings that we had, we were able to modify it and really come up with a much better plan. We got everybody involved, like Mary mentioned. We have Chamber of Commerces were involved. They were informed about it. All surrounding towns, chiefs of police, all hospitals were involved. Trucking companies were told. Schools were informed. So we really didn't leave, even like Mary mentioned, the FBI, actually even the White House and Secret Services were involved, were informed of the weekend closure. This is a national highway, and it's a national highway system carrying about 100,000 vehicles a day. That, you know, we need to make sure we have everything. And the contractor, we had a contingency plan. We weren't 100% comfortable, but we knew everything. We dotted our I's, crossed our T's. We looked over and over. We knew that it's going to work, but we still, that, like I said, that 1% factor that we weren't sure that it was going to, we could make it. This was also the detour notification strategies. We used the ITS system, we used the cameras, we used the alert system with the neighboring states. I've seen signs myself coming from New Jersey or New York that they were put out for us. We had state police basically put about 27 troopers for that weekend, each shift. All the ramps, all the leading highways. We had local fire, and even like I said, AMR was on site. We have we established the project website for the department that everybody can visit, and also from there they can link into the cameras that we have. And this is the last slide showing the final product. We end up rebuilding the road as a nice gesture to the town. We don't want to leave it in a bad situation, and that was very successful. Everybody liked that. And lessons learned, I just want to go quickly over that. You see the lessons learned. Lighter, we know that we use precast concrete just because the situation, we don't want to change a lot with at this time. The maximum grade for SPMTs was very important. We used, like I said, we thought we were 3.5%, 2% based on the load analysis was adequate. A travel path, we didn't realize that. We thought we had 40 feet based on our concept. But once we got into it, we needed about 58 feet on Marion Avenue, so we ended up doing some widening. Incentive, disincentives, we believe we need more thoughts going into that ahead of time, and not it was a last minute for us. Advanced utility, we need to do a project, what we call utility breakout projects to start that, and intelligent monitoring system, management system. We had few that we needed to locate ahead of time. Local review of traffic plans, we should get them involved early, the towns, the police, and everybody, the fire department, anything that would affect the major route in there, that was very important, and we should get them early on that. The use of alternate methods, we're talking about hopefully design build or manager at risk, contract construction manager at risk. We're looking at those for the future. Time for work and drawing, it worked out good for us, but there was so much to review that by us delaying the notice to proceed and award date, it helped us a lot that we had used the winter time to review the plans. There was so much. Staging areas, contract items, we could include more on the contract or make it part of the things. Bearing plate change, we only showed one size, and we needed a lot for one bearing to move up. So we suggest that we use different sizes and just mention them in the detail. Contractor survey, we need to make sure we go through that, make sure the survey is done correctly. And also one of the things we did restrict all the projects from working on that weekend. We don't want anything to affect detour routes in the state. And site accessibility is very important. We were lucky with this particular site that we did in here. And we did open for final paving, marking, and everything at 440 eastbound and 815 for westbound. And like I said, we're supposed to open Monday. We had the Monday 5 o'clock in the morning. And I'm going to turn over.
I think we could just play this video here.
To play a video. You may not hear the sound, but this was a time-lapse video that was done for EarthCam that we added to the project. So please enjoy watching. And
so we made out pretty well with the closure on 84. Friday night, we didn't get the backup that we expected. So Terry had the estimate of how many miles. It wasn't even 2, I don't think, at the start. And people were able to flow through that site with the one lane. One thing I'd advise is we just have the barrier. It might be nice to have some screening because the traffic actually slowed down to see what was happening in our work site because it was so interesting.
Thank you, Marion. Mohammed, I just wanted, Tim Fields again here, I wanted to say a few words, you know, ABC looking ahead for Connecticut DOT. Right now we have 2 lateral slides in the works. These 2 projects, one in Waterford, I-95 over Oil Mill Road. That's anticipated to be in construction 2016. Another project in Norwalk, 102-295, that again I-95 over Connecticut Avenue. We have 2 lateral slides. That'll be 2017, we expect. We also have 2 projects in the works involving SPMT superstructure moves. One in Stamford, one over I-95, that project scheduled for 2017 construction, and another unusual project in Stamford, 135-301, which is a replacement of a Metro North railroad bridge, a 5-track railroad bridge, where the span is going from a single span to a 2-span, with underclearance being improved from 2 lanes to 6 lanes. We'll be using SPMTs as part of that, which is probably one of the most challenging projects that we have in the works right now. I would like to say that those projects we selected, you know, that type of ABC construction based on construction cost and user impact here. So these, those 4 projects I mentioned here, we're not putting a undue premium on SPMTs or lateral slides in conjunction with construction costs. We also have about 15 other projects of much smaller scale, some GRS, IBS, some culvert replacement, and some rigid frames using precast elements, including all substructure units. So I feel we're moving ahead soundly into ABC, and to help us with our decision making, we've developed this ABC decision matrix. This is similar to Utah's DOT with some variations we put into it to fit better for Connecticut. But this is a decision matrix that we would use on projects involving deck replacement, superstructure replacement, and entire bridge replacement. This decision matrix would be used during the preliminary design phase before we get to design approval and final design determinations. But I'll just say there was a weighted table in that Mary, if you want to bounce back to the at the very lower right-hand corner is the matrix uses 10 measures, and those measures get drawn into an ABC rating table that has weighted factors. And then there's, you can't really see this easily, the viewers, but we have 3 rating categories: 1 favorable for ABC, 1 marginal for ABC, and 1 ABC not recommended. So that's where we are today. We've used this matrix on a pilot basis on probably about 6 different projects right now, and it's going to be very shortly issued for general practice across the board here at DOT. With that, I think we're concluding our presentation today on our Southington project. Yeah.
All right. Thank you. Thank you all for a great presentation. At this point, Ben Bierman is going to moderate the question and answer period.
Okay. Can you hear me okay?
Yes.
Yes.
Excellent. Okay. Mohammed, Tim, Mary, great job on the presentation. Great job on the project. Before we begin the Q&A, I'd just like to say, kudos for having that fortitude to do 2 bridges in 1 weekend using this method. It's not common in the U.S. I think this is the 2nd project site that we've seen in the U.S. where we removed and replaced 2 bridges in that type of time period. So hats off to you all for doing such a great job on that.
Thank you.
So, folks, we've gotten questions, about 20 pre-webinar questions, and of course, if you have more questions, pop them into the question pod, and we'll go through them. I grouped the questions into, I think I got 4 categories here. Let's see here. We've got decision-making, and I put decision-making and cost together. The other category is design. The next one, contract requirements, and of course, construction. So we'll go ahead and get started in that order. We'll start with some of the decision-making questions that came in. So, and they're really related to cost, and you guys really did cover cost very well in the presentation. So I'm going to kind of jump through. We all know what the project did cost, but one specific question was the vehicle delay cost. How much did that contribute to the cost estimates that we saw in part of the presentation? Were those actual cost dollars? There were pre-engineering cost estimate numbers, and then Mohammed, it looked like you had gone through what the actual costs were in your slides. But in the pre-engineered cost estimates or the pre-construction engineer cost estimates, were those numbers, did they fold in the user cost as well in those numbers?
Yeah, no, Ben, this is Mary. They did not. Those costs were just contract item costs, and on top of those were the engineering costs, and we did not calculate the user cost.
Okay, and then, but you probably did do some user cost on the side. Did that weigh in on sort of that decision-making process to say, well, we're going to try it this way?
No, that's not the case, Ben. We did not use a user cost analysis. Even our matrix right now, it doesn't address user cost per se. It addresses user delay and people days. So we haven't at this point made an attempt to assess a dollar value on user costs in terms of delay. here, and it wasn't used on this job. So, you know, this job had merits to advance an ABC design with SPMTs more or less independent of that. I think today, if we were doing this, we would use our matrix and we would have a better handle, at least on the user impact in terms of user delay over, say, a 2-year construction period where we're reducing traffic periodically to, you know, to 2 lanes into 1 lane versus the, you know, a much higher intensity during this weekend closure of I-84 when we did the SPMT moves. I would like to say this, that one thing that made this very successful in Connecticut was the advanced PR. That was huge, and encouraging people to basically drivers to stay away from this area. You know, we had very minimal backup on I-84 here, you know, despite you know, an 80,000 ADT here, you know, in this highway, and that wouldn't have happened without people, you know, being well aware of this project and choosing to avoid this area here in the state. So, you know, I think that's really a factor that needs to be promoted in doing these kinds of projects. Is, you know, we've emphasized this in the presentation, but to use your immediate as greatly as you can to get the word out, because that's really what made this successful. Otherwise, we would have had miles of backup on I-84. So, and we, at the end of the day, got very good press coverage, you know, as a result of the minimal impact on our highway system.
Yeah, and it sounds like the project built a lot of both public and political capital due to all its success. Yeah, and I guess regarding those user costs, I guess what that drives down to is that you're looking at actual project cost here. So, and I think that sort of sums that up. You know, we don't have to get into that component to kind of get into that justification.
I think key here is we need to sum up user costs and dollar value that you might come up with that to justify the use of the SPMTs here.
Mm-hmm. Now, you all talk, and I believe your state is probably one of the more advanced in terms of trying to capture what we call administrative costs. And I believe in the pre-engineers cost estimates, you did talk about that lightly. But, you know, the time frame to do an accelerated job versus the time frame to do something like this conventionally, there is your cost as an owner agency just to do the oversight. How much does that weigh into a project like this in terms of, you know, making the trade-offs going back and forth?
Let me say, Ben, at the time this job was determined to do the SPMT, we didn't have the framework of our matrix to work with. But if we were to have analyzed it at that time, there would have been a very significant overhead cost savings on the part of the department, because you're taking a job that would have been well over 2 years and compressing it into 230 days.
Yep.
So we actually, our matrix now has a method to capture, you know, that extended duration for conventional construction in regard to department overhead costs. That includes the construction trailers that would be needed for the job, and all personnel who would basically be billing time to the job. It's a kind of a rough formulation we have, but it's an attempt made to capture overhead cost of extended conventional construction as a comparison to what might be an additional ABC cost in using you know, ABC methodology here. But let me further say one key factor here in making the ABC approach very cost competitive is the overbuild that we would have otherwise been required to do on I-95. We would have had to put a temporary bridge in, widen the embankment, overbuild the new bridge. You know, those costs were, you know, were about equal to the SPMT moves. So not only did we have a wash there in cost, we had the advantage of the overhead savings with the department on a much you know, reduced project duration.
Okay, and I've got one more cost-related question. We'll get into the other categories, more like good nuts and bolts type stuff. But this one came up on your slide, Mohammed, when you were kind of giving your those numbers in terms of cost. There was a number showing a $6 million estimate and a final number of 7.4. And the question was, well, what was the difference between there?
Well, these were the extras that we weren't, you know, and basically like the incentive, the $200,000, that's an incentive that was done. We had about the shoring I was talking about in the westbound area that we had to put ahead of time under the bridge and then finally pick it up with that to become part of the SPMT. That was an additional cost for shoring and rental for that staging area was about $180,000. The IMS and the widening of Marion Avenue to make it 58 feet wide and taking out the sidewalks and excavation, putting that back, it was about $150,000 for that. And also we had the town police just working with the town police was $148,000 right there. There was something we didn't mention. There's a week before the move. We're supposed to move in June 20th. And there was a decision, there was a golf tournament going on, and PGA Golf Travelers Tournament. We didn't think based on our numbers that we would affect the tournament. However, the governor made a decision to delay our move 1 week. So those trailers that came from all over the country with the crew had to wait an extra week, and with costs and also traveling, they couldn't, it was 4th of July was coming right after. They couldn't get permits to move them around. So there was another, we settled about $200,000 cost and various other things. But these are the bigger costs that we had that added to the $7.4 million.
Okay. Now, and I'm going to just jump into the construction category type questions. They're really good. Well, I guess the question everybody wants to know is, did you see any deck cracking after the bridges were put in place after the move? Yeah.
No, after the move, none.
No, we have our bridge inspection division, and they came right out and inspected it because they were asking that same question. We had that monitoring, like Mohammed pointed out, Steer Engineering from Rhode Island was a sub too.
Yeah, I noticed. I'm sorry. I noticed on your SPMT setup that Barnhart did, they used what I'll call that inverted spreader beam, which allowed you guys to get the support of the SPMT coming up underneath the bridge, really closer, a whole lot closer to the bridge ends, which is kind of an important thing to consider when you're doing these. Did you all put? Yeah.
Stantec Consulting put some real thought into where the picking point should be, and in all the reviews of the move documents.
There may have been a little more flexibility if it was a steel superstructure, because we might have tolerated a few cracks in the deck, possibly, if that would, make the setup easier. But with a pre-stressed New England bolt T type beam, the supports needed to be towards the ends of the beams here. Anyway,
sure. There was one notice based on the monitoring we did and our own bridge safety that looked at it.
Actually, now, did you all put more resteel in the deck in anticipation that this was going to be a SPMT move, or was that pretty much your conventional deck resteel?
I think it was just a conventional. Yeah. Well, like I said, you had some more information in the article, but I don't believe that we did.
I don't think you would. No.
Probably not. If you would have heard about it, you would have. Some people, right, no. Yeah. Okay, so now questions about the demolition. So now, Mohammed, you talked about this. There was a grade issue, which really dictated that there were going to be two different demolition techniques that were going to be used here, which is really interesting. Can you elaborate on that a little bit? Did the contractor want to use SPMTs for both removals of the bridges, or was it sort of also a time cost equipment type strategy as well, or was it really just solely dictated on that slope issue?
I think based on their analysis, after they actually got to the point where they started doing the full analysis for the pick and found out how much the weight, I don't know if I mentioned, it was like the total move was 1,500 tons basically. So the bridges weighed 1,040 tons, and about 500 tons were for the SPMTs themselves with the cribbing on them and everything. So when they started looking at that and looked at the slope and the slopes of the road, they decided that it's easier to go the other way, and actually they thought that they could shave about, like I said, 12 hours So it was another thing to work towards their incentive. So by doing the westbound being built right next to that bridge and just making a short move there, they thought it was just in terms of more of a business decision for them and to shave time and to get the bonus. And I think that was the major factor.
Having removed them in two different ways, did you get any feedback from the contractor in terms of, is one better than the other, or, it's all dependent on...
Not really, no. They really haven't said any of that. But like I said, they thought it was better to do it that way, and it really worked out pretty good. The demolition didn't take much longer. I know in the picture you saw that eastbound was ahead of westbound being removed, but it did not affect much because, just a couple hours here and there. But the time was saved, and the time it would have taken, like I said, it was 0.3 miles per hour. If we gone from the staging area and had to do that travel, there was going to be a lot of time to get to that point, and a lot of more shoring and, to stabilize the load to get to the westbound side. So they decided it was a lot easier and safer and made business sense to do it that way.
Now, did on the bridge that was demoed in place, did they pre-cut that deck or saw cut the deck, or did they rubble the deck?
Just the day off. The day off. On Friday when we started, they had about a couple of crews. Manpower was very important in this job, and we had to make sure they had so much available to work on both bridges at the same time and do the horizontal cutting on the back wall and all that stuff. So no, it really right at the same point. They had about 2 or 3 guys cutting along the beams and then just doing the double pick.
Okay. All right. So they pre-cut the deck or saw cut the deck, then they dropped them down, correct?
Right. But that happened after we did the closure. Up to 9 o'clock, that highway was open. Don't forget that. So we didn't soak out ahead of time.
Okay. Now, when the new bridge came in, how did your beams, the beam bearings, set? Did you get full contact area? Did you have to use shim packs? Did they come down pretty good?
We did have to use the shims, and that's one of the things I mentioned as our lessons learned. We needed different sizes shims. We had a problem on one of the bearing pads, one concrete bearing. We had actually to take it out and rebuild it with that quick set concrete. That was one of the other things. Like I said, we're planning on finishing at 10 o'clock Sunday. This delayed us about 3 hours, having to modify one concrete pad. Due to an issue, again, it was surveying on the contractor part. That's why I mentioned in my lessons learned also, surveying is very important, double and triple check. There was only one concrete pad that needed to be redone. But the shims worked out pretty good. A lot of them were fine, except like a few areas we did have to use a lot of shims. But we were hoping that we should have specified different sizes, because I think all we had like 1/8 plates and shims, and we should have had different kinds, like 1/4 and the different sizes to be able to do the fit.
Okay. I'm seeing a comment from Mr. Henry Russell, who's apparently reading the Aspire article, and he did say, he noted that in the Aspire article that there was some additional resteel put into the deck to accommodate the SPMT move. So,
okay.
I wouldn't argue with that, because
that was written by Andy.
Andy was the designer of record on the job.
Thank you,
I would take his word.
Okay, we're getting close to the 2:10, so I got to be really selective on these next few questions here. So, what was the most unexpected difficulty you experienced during the project? It's a good one.
Well, like I said, the unexpected difficulty was that bearing pad, basically the concrete, and also we were ready by 1 o'clock, honestly, to open the highway, the eastbound. But it was a hot day, and the blacktop didn't cool off quickly enough to be able to put traffic on. So we had to get actually water tanks and water the full thing.
We're building up, right?
Yes. Yeah. So we were building up, again, the deck, 2 inches or 3 inches of blacktop and the approach slabs and the whole 9 yards, but it was so hot, and it didn't cool off on time. And the last thing was we were close, but there was our commissioner decided he wanted to come also and do a ribbon cutting. So that kind of delayed us another hour. I hope he's not listening.
The contractor's like, this one isn't on me, guys. All right, we'll leave you off with this one. Feedback from the contractor, and we'll close it out from there. After the job.
That's it.
Yeah.
Yes.
There was a quick question about the SPMT cost. It was bid at $1.5 million. So that was the bid we got for the cost of the SPMT for the project. It was an item for removing the bridges. So I just wanted to mention that.
And you had 4 bidders, and so, I mean, those are some pretty heavy incentive disincentives in that project. Did you get a lot of heat from that?
What I said on the disincentive, we did.
Just the understanding of it at the beginning, but we
Right.
clarified that during
The
that.
disincentive, like I said, when somebody calculated like waiting 2 days or 3 days if they couldn't open on time, it was going to be more than the cost of the whole project. So their surety companies were up in arms, and they started sending questions during the bid, and we had to cap it at $1 million.
So all of our unit prices are listed on the website too. I mean, the specific jobs, you can read them. Results, the bid results.
I got to close it out. Adirot's giving me the signal there. So with that, guys, thanks so much for doing the project as well as the webinar. With that, I'm going to pass the baton on over to Tora.
All right. Thank you, Ben. Thank you, everybody, for such a great presentation. It was very informative. And on that note, we will conclude today's webinar and hope to have you back next webinar. We are going to have another great presentation coming to us from Iowa. And I also hope that we see many of you in December in Miami at the 2015 National ABC Conference. And again, please remember that the deadline for online registration is November 20. So hope to have all of you back next month. Thank you.
Thank you so much.
All right. Thank you.